Welcome everyone to our class. Today we are going to learn how to draw the geological profile and cross section along a given line in any geological map, and we are going to learn how to interpret the geological history of the area. For that, today we have taken this map in particular. Look at the map carefully. It has got characterized by different traces of the beds. Together with the beds, we have got dissected lines which represents the contour lines in the area. The solid lines represents the traces of the beds. So 1, 2, 3 and 4 traces are present in this particular map. So we can calculate the number of bed in this map. So number of bed is given by number of trace plus 1, that is 4 plus 1 equals to 5. So here we have 5 beds. This direction is north direction. So with respect to north, this will be east, this will be west, and this will be south direction. The scale of this map is 1 inch is equal to 1000 feet. So how we are going to attempt this map? Like always, we will take first the topography of the area, then we will find out what are the structures present in this area, then we will find out the order of superposition of those structures, and ultimately we will reconstruct the geological history. So this map is characterized by 5 beds. Now we can interpret the nature of beds by seeing the relationship between the traces and the contour lines. So in the earlier map, the contour lines were parallel to the traces of beds. That signifies that these beds are horizontal. But in this particular case, we can see the contour lines are intersecting the beds. More than one value of contour line is intersecting one trace of the bed. It means single trace is lying at different elevation. That can only happen if we have situation like one particular trace is inclined. Suppose if this is the trace of the bed and it lies at one particular height, there will be only one contour line on it. But if it is inclined, then we are going to have more than one value of contour line because this trace is lying at different height. It means the beds in this map are not horizontal, rather they are dipping with some amount. Then if the beds are dipping, what is the amount and direction of the bed? We will have to determine it. For that, we will take help of strike lines and we will find out the HE and CI, and then we will determine the dip of these beds. So what we do, we determine the dip, but before determining the dip, we are now knowing that this area consists of 5 simple dipping beds. There are no structures which are being appeared in this particular area, so this area is simply composed of 5 simple dipping beds. Now which bed is younger and which bed is older? So we have a rule in geological maps that in the direction of dip we get younger beds. For example, I am going to draw a simple cross section of the beds. If this is horizontal bed, suppose there are 1, 2, 3, 4, 5 beds. So these are undeformed bed. So older bed lies at the bottom and youngest bed lies at the top by the principle of order of superposition. But let's say that this particular area has been put under some tectonic forces. So these beds are going to be dipped, or the area has been inclined. So if the area has been inclined, there will be erosion and exposure of the traces at different places like this. So if this is bed number 1, this is bed number 2, this is 4 and this is 5. So if we are walking in the direction of dip, this is the direction of dip. So we are successively getting younger beds. So in the direction of dip, we will get the younger beds, and opposite to the direction of dip, we will get older bed. If we are going to walk across the dip direction or opposite to the dip direction, in this direction, we are getting bed number 5, then we are getting 4, then we are getting 3, then 2, then 1 ultimately. So in the direction of dip, we get younger beds. So here, if we determine the direction of dip, then we can come to know about the younging of the sequences of beds. So in order to know the direction of dip, we will have to know the places where the strike lines are lying. So we can choose any one particular bed and we can draw 2 strike lines for those traces. So this is one strike line, we can draw a strike line by choosing 2 appropriate points where same value of contour line is intersecting the trace. So here this is the value of 400 which is intersecting the same trace at 2 places, one here and one here. If we join these 2 lines, these 2 points are at single height, so this will give us one strike line. This exercise you will do with the help of pencil, but for clear visibility I am using the pen. So here the value of this strike line is 400 because this is formed by intersection of 2 points which are lying at a height of 400. So at this place and at this place, this trace is lying at 400 feet. So value of this strike line is 400. Now in order to know the dip, we need to know that what is the value of or where the next successive higher or lower strike line is lying. So we will have to find out another contour line which is intersecting the same trace. So this is another value of contour line. This is 300. This is intersecting it here, here, here and here. It means at 4 places this trace is lying at a height of 300. So we need the nearest point, and parallel to this line, earlier strike line, we will form the another strike line from where the value of 300 contour is intersecting the same trace. So here we have 4 points. So we have choose the nearest one and drawn a parallel line to this particular earlier existing strike line. So this strike line is of 300 value. So what will be the direction of dip? Now in order to determine the direction of dip on our concern line, let's first draw the line along which we'll have to make the geological cross section. So for this we will use pencil. Take out the pencil and draw the line along which you are supposed to draw the cross section. So this is that particular line XY along which we have to draw the cross section. So here this is 400 and this is 300. So how the direction of dip is determined? If this strike line is of lower value and the higher strike line will lie at higher values. So the dip direction is from this to this. It means from higher value to lower value. It means in this particular map, the dip direction will be from higher value of a strike line to lower value of a strike line. So the dip direction will be north-south. This is the strike line and dip is always perpendicular to the strike line. So this is the direction of dip and this is north. So the beds are north dipping and they are striking east-west. Then we have solved the problem of direction of dip. Now in order to draw the cross section, we do not only need the direction of dip, but we also need the amount of dip. So how amount of dip is determined? So they are simply related with a triangle. Like if we have one bed having dip like this, so we can draw the two strike lines. So here we have one strike line having value x, and here we will have another strike line having value x plus 100 because there is a difference of 100 feet. So this is the angle of dip, theta, because we take the dip as angle from horizontal. So this and this are alternative angles, so this will be theta. So if we have this value and this value, we can come to know the dip angle. So this value is known as horizontal equivalent and this value is known as CI. So contour interval CI is nothing but it is contour interval of the map. This is 100 feet. That is, by scale we have 1 inches is equal to 1000 feet. So 100 feet will be equals to 0.1 inches. So if we have this CI and we have HE, we can find out this angle. So CI can be determined from the map. This is 0.1 inch. And we have to find out the HE in the direction in which we have to determine the dip. So we have to determine the dip in XY direction because we have to draw the map along XY. So we simply measure this distance. So either we can measure this distance with the help of divider and mark it at other place, or we can put our CI over here. So this will be HE. And now if we put CI, that is equals to 0.1 inch over here. So this is 0.1 inch. And now make a triangle. Make this triangle carefully because simple error will lead you the error of at least 1-2 degrees. So here we have drawn this particular triangle. So this is CI and this is HE. So this will be theta. This angle will be theta. Now we can measure this angle with the help of a protractor. So here this angle is roughly 6.5 to 7 degree. So we are going to take it as 7 degree. So we have determined the dip angle. Dip angle theta is equals to 7 degree. So in drawing the section we are going to use this value. Because this is the direction of dip, it means this is the Younging direction. So opposite to the direction of dip will be the older bed, and in the direction of dip there will be younger bed. So this is in fact the bed number 1, that is oldest bed. Then this will be the bed number 2, this will be bed number 3, this will be bed number 4, and this will be bed number 5. So now we have got 5 beds, and we have also got the ages of the beds or relative ages of the beds. This bed is the oldest bed and this bed is the youngest bed, right? So now we have interpreted the age of the beds and nature of the beds. Now we can interpret the geological history of the area. So because these beds are inclined, but we know that whenever the deposition takes place, it takes place in horizontal manner. If any deposition occurs in sedimentary basin, the nature of deposition is horizontal. The beds initially deposits at horizontal manner. But if you are getting certain inclined beds or folded beds or faulted beds, they are produced because of deformation of virginally horizontal bed. So here now it is deformed because it is not horizontal, rather it is inclined at certain angles. So we can interpret history of this particular area by knowing the ages of the beds. So we have already determined the ages of the beds in relative terms. So this is the oldest, this is the youngest. It means the bed 1 must have deposited first, followed by the deposition of bed number 2, 3, 4 and 5. So we can interpret the history like the bed number 1 was deposited over an unknown basement because we don't have any idea about the lower trace of the bed number 1. This unconfirmable deposition was succeeded by confirmable deposition of bed number 2, 3, 4 and 5. So if any deposition occurs initially, that deposition is in fact unconfirmable because we do not have any idea about the basement of that particular basin. So basement may be of any age, then another deposition that will occur. This first deposition is unconfirmable, but we have idea about second deposition. We know the base of this particular second bed, so this is confirmable. This is again confirmable, and another depositions will be confirmable in nature. So the bed number first was deposited unconfirmably over an unknown basement, followed by confirmable deposition of bed number 2, 3, 4 and 5. Then because this deposition produced the horizontal beds, then we are saying this bed as inclined. It means the area was uplifted and it must have been tilted or inclined during or after the upliftment. Then the area must have been eroded to produce the present day landform. Now we have to draw the cross section and profile of the map. For that we have a plain sheet of paper which we will put over here. And now either we can make strip and mark the value of contour lines and traces of the beds, or we can simply fold this map so to find out the x and y points, and we can mark the contours and traces of the beds with the help of this particular folded map. This will act like a strip only. So first we are going to mark the point x and point y. These 2 points, by joining these 2 points, we will find exact same length line as we have cross section line, and this is going to be the base line. So we have to mark these points such as so that they are symmetrical in page. We are going to turn it because this is just in between, and we will mark these points back again. So here is point x and here is point y. In between with different colors we will mark the traces of beds. I am marking the traces of beds in red color. This all exercise can be done with a simple pencil, but in order to distinguish and show you, I am marking it with different colors, and I am going to mark the contours with green color. So these are the points where contours are present. Now we have to write down the value of contours. This value is 800, this is 700, this is 600, this is 500, this is 400, and this is 300. Now we already have baseline, the points for the baseline. We will join these points. So this is our baseline. Now we need to mark the value of contours onto this baseline. So here we have the value of contour lines ranging from 200 to 800. So here we can mark these values 1, 2 for height 3, 4, 5, 6, 7, 8, 9. We will mark it with some interval so that the data is clear. So this is baseline. This will have 0 feet value from the mean sea level. This will have 100. Then we have 200. We are not marking 200. We are marking 300. If 300 after 400, mark the 500. We'll mark these values which we are leaving at another side. Then we have 700. Then we have 900. In between we have 800 and 600 as well. This is 1000. In this side we will mark the even values. We are marking this with an interval because we have to make the map clear. So here we have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and this is 1000. So this is 0 again, and this will be 200. In between we have 100. This will be 400. This will be 600. This will be 800. This will be 1000. And in between we have 900, we have 700, we have 500, we have 300, and we have 100. Since we have already marked the position of our contour values at the baseline, so we will have to project at that height. So this is 800, we will have to project it at 800, and here it is 700, we will have to project this point 700. This is 1000, 900, 800, this is 700. So we'll have to mark it here on 700 point. Be careful, mark these lines, these points just above. This is 600. This is 500. This is 400. And this is 300. So if we are going to join these points, as we can see over here in the map, that this value is 300, the 200 is not intersecting. It means this point is going to lie in between, the y is going to lie in between 300 and 200. So here we have 300, but here it is going to meet in between the 300 and 200. And above, if you see, this is the point x, this is point here, this is point x, and this is point y. right? So here this point X is lying beyond 800, but 900 is not there. It means this point X is in between 800 and 900. So in order to make the profile, we will have to join these value of contours with a rough hand. So here we are going to join in between 800 and 900, because 900 is not present and the value is in increasing trend. So rather than marking between 700 and 800, we will choose the 800 and 900. We will mark this with a rough hand. We will join all these points with a smooth hand rather than by joining some scale or joining sharply. So this is between 200 and 300, so that we get natural sloping pattern of the ground. So this line is in fact the profile along XY. So if you start walking from X to Y, here we are seeing that the value of contour is 800, then 700, 600, 500, 400. So height is gradually decreasing. You are walking somewhat like this. So here you can perceive it. You are starting from X. X is not actually here. X is here. Now the height is represented in this direction. So here we start walking from X and we get these points. We have to draw it with a smooth hand, and we don't have to draw very thick line. We will remove the earlier formed line and we will form one sharp line above this smooth line, and we will remove the earlier present lines. So now we have drawn the profile. Now we have to mark the beds onto the profile. As you start walking from X to Y, this is X, this is Y. So if you start walking from X to Y, you get one bed up to this point. Means if you are walking over here up to this point, you are going to get one lithology. Then from here to here we get different lithology. So here to here we'll mark with some colors so that it is clearly visible. So here this is the point, and this is another point, and this is another point, and from here to here we were getting one lithology, and from here to here we are getting different lithology. So this is the point. Since we know that beds are not horizontal, beds are dipping. And in what direction the beds are dipping? The beds are dipping from higher value of a strike line to lower value of a strike lines. It means the beds are dipping from Y to X, and the amount of dip is 7 degree. We have already determined, and the dip direction is from Y to X. So in order to draw that dip amount, we take any appropriate point at the base. Let's say this is the point, and we mark that 7 degree amount with the help of protractor. Because the dip amount is 7 degree, it is roughly 6.5 to 7. So we are going to mark as 6.5, in between 6.5 to 7. So here we have marked. So we are getting a reference line for 7 degree dip or 6.5 degree dip. So this is the dip angle theta, that is equal to 7 degree. This is actually 6.5 degree. I have drawn the 6.5 as well. So now we have to draw the beds so that they are dipping with the same amount in this direction. For that we can take help of another protractor to keep it parallel. So we keep a protractor like this, the set square in fact. So if you are going to keep a set square, so it will restrict the movement of another set square in this direction only. And now you can draw a line like this. So this is our first bed. From another we can draw point. From another point we're getting one more over here. And we have one more point. So simply draw a line parallel to 7 degree. So here we have got the beds, that how they are going to be present within the subsurface. This is the surface data. The map is in fact the bird eye view of the area, and we have to draw the cross section, that is how these beds are present in the ground. So these beds are present like this. Now we have drawn the cross section of this particular area. The another exercise that remains is to fill the symbol. So this is the bed number 1 in which we will have to fill the blue dots. So this is bed number 1. And another point is black in color. We are going to use this pen for that. So second bed is of lower sandstone. The first bed is lower shale. And third bed is mudstone, that is represented by this type of symbol in the map. Then fourth is represented by triangular dots of red color. So this is bed number 4, and 5 is not having any symbol. So simply you draw a smooth line. So this is our profile line and this is cross section. In order to make it more visible, I am going to draw these lines with the help of pen. But this exercise in the file will be done with the help of pencil only. So here it is the cross section of a given map along line XY. So here we will have to mention a geological, write with the help of a sketch pen so that it is visible. Cross section along line XY. So this was our exercise. Now we have to draw the details of the symbol, because a map contains symbol. We'll have to write down about the symbols. So this is lower shale. Then we have lower sandstone, that is represented by this symbol. This is lower sandstone. We are writing in short SST. Then we have third bed as mudstone, and mudstone is marked by green color. So this is our mudstone. And then fourth bed we have is lower sandstone. Upper sandstone is represented by 3 dots put together. So this is our upper sandstone, and then at last we have upper shale, which is divide of any symbol in order to distinguish these all beds. So this is our cross section along line XY. Now, in order to discuss this, we discuss these things in 4 points. So the very first point is topography. So in topography, we can see from the map the lowest value of contour line is 200 and highest value is 800. It means the lowest relief is more than 100 feet but less than 200 feet, and highest relief of the area is more than 800 feet but less than 900 feet. So we will mention about the lowest and highest relief in the topography, and we can see from the profile that this particular topography is represented by a sloping ground, and the slope is from x to y. X direction over here is in north and y is south, so slope is from x to y, that is from north to south, and the strike of these beds are in east-west direction. The second point we discuss after topography is a structure present. So we have 5 simple dipping beds. Then another thing we have to discuss is order of superposition. So in order to determine the order of superposition, we make the balanced cross section of the area that represents the order of beds in undeformed manner. So we have 5 beds which are dipping, but here we are not going to draw it in dipping manner, rather we are going to draw it in undeformed manner. So bed number 1 will be at the bottom and youngest bed, that is 5, will be at the top. So bed number 1 over here is lower shale, that is represented by 2 dot. We'll fill it like this. Then we have lower sandstone. So lower sandstone is represented by a symbol like this by the pen, somewhat light. Then we have mudstone, that is represented by green dot. This is mudstone. And then we have the lower sandstone, upper sandstone, and we have upper shale. So this is order of superposition. It means the bed lower shale was deposited over unconformable basement, and here after lower shale the deposition of lower sandstone took place, and after lower sandstone the mudstone was deposited and was followed by the deposition of upper sandstone, and upper sandstone was succeeded by the upper shale. Now the geological history of the area. Geological history of the area. So the lower shale was deposited over an unconformable basement. Lower shale, within the bracket we will write down the symbol of lower shale, was deposited unconformably over an unknown basement, because we do not have any idea about the lower trace of lower shale. This is the first bed. Then we have conformable deposition, because we now have idea about the basement of other beds. So followed by conformable deposition of, we have this lower sandstone. We'll fill the symbol for lower sandstone. Then we have mudstone. Then we have upper sandstone. And at last we have upper shale. So up to now we have deposited like this. We have interpreted the history, this deposition 1, 2, 3, 4 and 5. But because we are getting sequence like this 1, 2, 3, 4 and 5, so we will have to interpret how it has been tilted. So this was deposited conformably, this was followed by, and then the area was uplifted and tilted. So tilting has been taken during or after the upliftment. Right? When the area was uplifted and tilted, so tilting has been taken place during or after the upliftment, and eroded to form the present day landscape or topography. So today we have studied about the simple dipping beds, how to make the profile and cross section of simple dipping beds. In the next exercise we will be doing the more exercises related with simple dipping beds and more complex structures. Thank you.